Class 10 Science, Chapter 1, Chemical Reactions and Equations, Part 2, Types of Chemical Reactions. Also watch Part 1 of this video in which I have discussed balancing the chemical equations. First, let us discuss the types of chemical reactions. So, in this chapter, there are 5 types of chemical reactions: combination reactions, decomposition reactions, displacement reactions, double displacement reactions, and redox reactions. Now, we will discuss them in detail with the help of various examples. First, combination reactions. So, the meaning of the word combination is to combine. So from the name itself, you can judge the definition of the reaction. So combination reactions are the reactions in which 2 or more reactants combine to form a single product. The reactants are the substances which undergo the reaction, and the product is the new substance formed after the reaction. So in this reaction, the symbolic form would be reactant 1 plus reactant 2 is equal to product. Examples of combination reactions. First, now we will study the reaction between calcium oxide and water. So calcium oxide and water react to form calcium hydroxide. So in this reaction, there are two reactants, calcium oxide and water, and only a single product, that is calcium hydroxide. So therefore, it is classified as a combination reaction. Calcium hydroxide is used for whitewashing the walls. So it has a very important usage. Now how it is used, let us study that. So when calcium hydroxide is put on the walls, in few days it reacts with the carbon dioxide present in the air to form calcium carbonate and water. Calcium carbonate is a very shiny substance and it gives a shiny appearance to the walls. So in this way, the walls are whitewashed. Second example, burning of coal. Burning of mostly all substances is classified as a combination reaction, as in this 2 or more reactants combine to form a single product. Also in burning of coal, carbon and oxygen combine to form carbon dioxide. In all of the above reactions, a large amount of heat is released. So such reactions are known as exothermic reactions. So exo means releasing and thermic means heat. So therefore exothermic means heat releasing reactions. Another example of exothermic reactions would be the burning of magnesium ribbon, which I have also discussed in my first video. So in this reaction, magnesium and oxygen react to form magnesium oxide and a lot of heat is released. Decomposition reactions. So as the word decompose means to break down, so in these reactions, a single reactant breaks down to form 2 or more products. So symbolic form would be reactant is equal to product 1 plus product 2. Examples. Now let us discuss the examples of decomposition reactions. So the first would be electrolysis of water. Now this is a process in which water is breaks down into its oxygen and hydrogen when electricity is passed through it. So if you keep water in a flask and then pass electricity through it, then it will be break down into oxygen and hydrogen. Second, decomposition of silver chloride and silver bromide. Have you ever observed, if you keep silver chloride and expose it to sunlight, then it turns grey. Now this is because of the decomposition of silver chloride into silver. Similarly, silver bromide also, when exposed to sunlight, breaks down into silver and bromine gas. And silver chloride breaks down into silver and chlorine gas. These reactions are used in black and white photography as they are light sensitive. Third, heating of lead nitrate. Now this results in the emission of brown fumes. So let us understand the reaction. In this reaction, lead nitrate breaks down in the presence of heat, breaks down into lead oxide, nitrogen dioxide and oxygen gas. So in this also, a single reactant is breaking down into multiple products. Have you observed that in all these reactions, electricity, light or heat are absorbed? So such reactions in which energy in the form of heat, sunlight or electricity is absorbed, they are known as endothermic reactions. Endo means to absorb and thermic means to heat. So heat absorbing reactions. Third, displacement reactions. The reactions in which a more reactive element displaces a less reactive element from its compound, these are known as displacement reactions. Now we will understand with the help of an example. So consider a fat person and a thin person seated on chairs. So if the fat person has to sit on the thin person's chair, he can easily pick the thin person up and sit on the chair. But if the thin person has to lift the heavy fat person and sit on his chair, then obviously he will not be able to do so. So similarly, in chemistry, the more reactive element can displace the less reactive element and take its place, but the less reactive element cannot displace the more reactive element and take its place. These are such reactions in which the more reactive element displaces the less reactive element. They are known as displacement reactions. So as you can see that these reactions are related to reactivity of the elements. So first we'll have to learn the metal reactivity series.
Please watch my video on how to memorize metal reactivity series, in which I have shared how to memorize metal reactivity series with the help of very easy and funny tricks. I have provided the link to this video in my description box.
Now we have come to the examples of displacement reactions. So when an iron nail is dipped in copper sulfate solution, which is blue in color, the solution turns green after some time, and also a reddish brown coating is observed on the iron nail. So this is basically a displacement reaction. Now let us understand the reaction. So in this reaction, iron and copper sulfate solution are the reactants, and the iron displaces copper from the sulfate solution to form iron sulfate solution, which is green in color, and the copper which is displaced gets deposited on the iron nail. But if we try to do the reverse of this reaction, that is, if we try to react, if we add copper to iron sulfate solution, then will any reaction take place? No. Because do you remember the metal reactivity series? In that, iron is at a higher level than copper. So iron is more reactive than copper, and copper cannot displace iron from its solution, but iron can displace copper from its solution. Now we will do another reaction. Consider that zinc is added to copper sulfate solution. Then will it be able to displace? So zinc has a higher metal reactivity than copper. So it will be able to displace it. Fourth, double displacement reactions. So in these reactions, exchange of ions takes place between the elements. So in this, one reactant displaces the other, and the second reactant displaces the first. So how is this possible? Let's see with the help of example. So let's consider example of sodium sulfate plus barium chloride is equal to barium sulfate plus sodium chloride. So in this, on the reactant side we have sodium sulfate, but on the product side we have barium sulfate. So barium has displaced sodium in this, but in the reactant side similarly we have barium chloride, and in the product side we have sodium chloride. So in this, sodium has displaced barium. So in this way, both barium and sodium are displacing each other from their solutions, from the compounds. So such reactions are known as double displacement reactions. Now in this reaction, barium sulfate, which is a insoluble solid, also known as a precipitate. This is produced. In all double displacement reactions, a precipitate is formed, and precipitate is nothing but a insoluble solid. So all double displacement reactions are also known as precipitation reactions. Fifth, redox reactions. These reactions are the short form of reduction oxidation reactions. Now let us understand what is oxidation and reduction. Oxidation. So as the name suggests, it is the gain of oxygen to any substance, or it can also be seen as the loss of hydrogen, because oxygen and hydrogen are opposite to each other. So we can see oxidation as either gain of oxygen or loss of hydrogen. For example, if we take the reaction between copper and oxygen to form copper oxide, that is Cu plus O2 is equal to CuO, then here copper is being oxidized as it is as oxygen is being added to copper. As you can see that on the reactant side it is Cu, and on the product side it becomes CuO. So O, that is oxygen, is being added to it. Reduction. So this is the opposite of oxidation. So oxidation was gain of oxygen, reduction is loss of oxygen, or it is the gain of hydrogen. So example, so now we will take the opposite reaction. So in this reaction, copper oxide is being decomposed into copper and oxygen. So CuO is equal to Cu plus O2. So in this reaction, copper oxide is being reduced to copper, if we see it with respect to copper oxide. So as copper oxide in the reactant side is CuO, but on the product side it becomes Cu. So it has lose the oxygen molecule. That's why it is being reduced. In all of the above reactions, one substance gets oxidized while the other gets reduced. So therefore they are known as redox reactions. For example, if we take the reaction of copper oxide plus hydrogen is equal to copper plus water. So in this reaction, copper oxide, that is CuO, is getting reduced to copper, that is Cu, but H2, that is hydrogen, is getting oxidized as it is becoming H2O in the product side. So oxygen is being added to it. Effects of oxidation. So now let us study what are the various effects of oxidation process. First, corrosion. So corrosion is the process in which metals are eaten up gradually by the action of air, moisture or acids on the surface. For example, when an iron object is left in damp air for a long time, it gets covered with a reddish brown coat known as rust. This is known as rusting of iron. Rancidity. So, have you ever observed that if you keep chips, biscuits or other goodies outside for a long period of time without keeping them in airtight containers, then their smell and taste change? This is because they get slowly oxidized. The fats and oils present in them slowly get oxidized, and this process is known as rancidity, and it spoils the foods. Methods to prevent rancidity. First, antioxidants. These are the various substances or chemicals which prevent oxidation. Second, food should be stored in airtight containers. Third, rancidity can also be prevented by storing the food in refrigerator. Fourth, bags containing chips and other oil and fat containing products should be filled with unreactive gases such as nitrogen to prevent oxidation and to keep them good for a long period of time.